a huge project, and you're very lucky because there is a very nice guy to present you that project. So Josh Matthews is a Mozilla engineer who is working on a lot, really a lot, of different things, including private browsing, Servo, and contributor engagement. He is also Mozilla module peer for geolocation, cookie, and private browsing code. And he is the creator of Bugs Ahoy, a tool that helps you to do your first patch. This is really an incredible tool, so you're more than invited to try it. And Josh is also, and I can testify, an excellent musician. He is singing for a group, plays kettle drum, djembe, and also guitar when he isn't busy doing anything else. So please welcome Josh.
Cool, thank you. And thank you all for coming. So I'm going to tell you about Servo and what we're doing with it and what it is and why it is and answer all your questions, hopefully. And also tell you how you can get involved. So first, what is Servo? So Servo is a brand new browser engine. And so a browser engine is something like Blink or WebKit or Gecko. So instead of the whole browser, it's just the bit that renders the website, executes the script. And in particular, Servo is written in a new programming language that Mozilla is creating from scratch called Rust. And we've been working on that for several years now. And it's nearing version 1.0. So Servo is a new engine which is designed to exploit modern hardware. And it's designed to really focus on performance and safety. And I'll explain more about those in particular later. Also, we're trying to make it so it's really easy to embed. We're going to build it behind the WebKit embedding API so that theoretically you could just take any current browser that uses WebKit and swap out Servo under the covers and it would just work. As for what it will be in the future, it's still hard to say because technically it's really a research project and it's being worked on by the Mozilla Research team. But we suspect that a good target for it would be some kind of mobile product in the future. So when I tell people about Servo and how we're creating this new engine from scratch, they often look at me like I'm a little bit crazy because building a browser is hard, it turns out. But there are good reasons for this. Basically, all of the browsers that you're used to using were designed before the year 2000. And hardware at that time was very different. You usually only had one core, clock speeds were very different, you had much less memory available to you. And so things like multi-thread programming weren't built in from the start, and they've been sort of bolted on after the fact. So the problem with existing engines is that they are giant, and there are various architectural decisions which are built into them, which it's very difficult to modify, it turns out. And it's really hard to run experiments to find out whether it would be worth committing to doing like big rewrites to take advantage of modern hardware, because that's a huge investment for something that may not actually work. And so the third point I want to talk about is that security and performance are hard. And so you might look at me and say, well, if it's hard, why are you starting from scratch again? But we know they're hard, and we know this because there are exploits in every single browser engine every single year. And that doesn't change. And performance, there's a constant race to get a little bit faster than the other engines. But often you're working against the architectural constraints that are imposed on you by the existing code. So we think that we can do better on both security and performance if we build it from the ground up with the understanding of the problems that we have from years of experience. So here's your basic modern browser architecture. If you go to fetch a page, you hit the network, and then that feeds into the HTML parser, which parses it into a DOM tree, which then gets computed into geometry. And that just means you take the elements of the page and you lay them out according to where they should be, and you take the result of that and you feed that into a renderer so you can paint it on the screen. And once that happens, then you want to start executing JavaScript. And the JavaScript can modify the page content. It can append elements to the DOM tree, and so then you need to recompute the geometry. And so there's a little loop here that just keeps going back and forth. Now, modern engines will often be able to do things like do the actual painting to the screen in parallel, and so then you just have a little loop between computing and executing. But even still, there's a lot of serial and sequential operations here, which we believe we can do better. Now, you have engines like Blink, which do things like have a different process per tab. And so that's one way of exploiting parallelism, because that way tabs can operate independently. But even still, you still have serial lines of execution within each tab. And again, this is somewhere where we believe that Servo can improve on the state of the art. So here's the Servo architecture. Basically, if you have a tab, or you load a page, and we create something called a constellation. And that's just a box, that's just like something that allows Servo to talk to something we call pipelines. And a pipeline in this case is like that serial execution that you saw before. So a pipeline encapsulates a script task, a layout task, and a renderer task. And I'm saying task because Rust is a programming language that is built around an abstraction that is like threads called tasks, but it's sort of like green threads if that means anything to you. It's threads that can make a little bit better use of your processor sometimes. So in Rust, a task is isolated, so there's no shared memory between them, and it's all message passing. And so in this case, these boxes mean that the renderer will be operating in parallel with the script task, and the script task will be operating in parallel with the layout task. And so these are all isolated from each other, and they all get to run at their own speeds. So if you have a single page which just has a bunch of content on it, you'll get a pipeline, and all these things can happen in parallel. There's still a little bit of serialization, because obviously you need to have something laid out before you can render it. But after that, then if you do something like resize the window, then the layout can happen independently of painting your existing content. And so you get a much smoother experience that way. Now, Servo's a little bit different because we can also break this down into iframes on a page. And so in an engine like Blink, you'll have an iframe, and the contents of the iframe will have to be computed before the rest of the page can be computed. Whereas in Servo, these can happen in parallel sometimes. So if you have a page in Servo with an iframe, we have a separate isolated renderer for that iframe, which will do its own painting into the place on the page where the iframe exists. And you'll have your own separated, isolated layout task, which will be computing the geometry for the iframe contents. And then the overarching page containing the iframe will then just get the results of that and be able to lay out everything around the box without having to wait on it. Now, it's missing a script task here because there's a special case for iframes. If you have an iframe which shares an origin with the enclosing page, that means they're actually able to interact with each other. And so it's not safe to have both of their pieces of script running simultaneously, because then you get race conditions. So in this case, they'd be running, only one iframe would be running script at a time, but everything else is happening in parallel. Now, the other architectural advantage to Servo is that if you have a cross-origin iframe, for example, an advertisement, we're all used to seeing those, we can take advantage of the fact that those are not allowed to interact with the enclosing page's DOM. So that means it can have its own script task. So suddenly, you have an add iframe, which might be doing something really bad. It might be using more CPU than you would prefer. And so in something like Firefox or Blink, that would be a problem, because that would be interfering with the execution of the enclosing page. But in Servo, that doesn't have to happen. And in addition, if something goes wrong in Servo's code and we fail an assertion, what we can do in this case with this isolation is we can just tear down that iframe and display a little unhappy face, and the rest of the page can continue operating normally. This is something that no other browser engine can do at the moment. And in addition, we get coarse parallelism just like any other browser, because all of this can be replicated in its own isolated fashion for each tab. So this is pretty exciting. So Servo is also experimenting with other really interesting research problems. And in particular, parallel layout is something that we think we can get big wins. So regular layout in any modern browser engine proceeds sequentially. So you'll start at the top, and you'll need to go to each child element, and you'll need to lay it out on the page and figure out where they exist, because other things at the same level will require that knowledge in order to lay out themselves. And so there's optimizations that browsers do where they'll reach all over the DOM tree and try to find where other things are and see whether they actually need to care whether those elements have been laid out. And if not, then they can do optimizations to skip parts of the layout. And this is how we achieve performance optimizations in modern browser engines. Now, with Servo, we think we can do better. What we can do is we can break it down. And for certain classes of web pages, we can say we don't actually need to care about the other parts of the page. We know that we can lay out certain parts of the tree independently. And so those can be farmed out to other processors and other isolated tasks. And in particular, we don't even have to do subtrees. We can just split out individual children and use techniques like work stealing to make sure that all of your processors are always fully engaged in laying out a page without having to resort to sequential operations or have problems based on like if the left tree was really deep and the right tree wasn't. With work stealing, we can get optimal processor usage. And so this parallel layout, some people look at it and say, well, most of the time layout is only a really small fraction of overall time when rendering a page. And so parallel layout won't make a big deal. But that's not true on mobile. Because on mobile, we're often a lot more resource constrained and there's much fewer processors. And so layout often takes maybe 10 times as long as on a desktop machine. And so parallel layout in this case could make a very big advantage. And we can also get power benefits because one processor working at full capacity will consume a lot more power than several processors working at much reduced efficiency, but operating in the same amount of time. And so we think that we could get much better battery life improvements out of a browser like Servo that has these improvements. And so there was a discussion on the Blink mailing list recently about whether they could implement parallel layout in Blink. And after a bunch of discussion, they decided that it would be far too big a change, and they didn't want to invest the resources for something that didn't necessarily promise to yield equivalent gains. And so what's nice in Servo is that we can actually guarantee, so we put in the effort to implement parallel layout. And that's exciting. We turned it on last week, and we're now seeing performance improvements where we're doing better than WebKit on some micro benchmarks. So that's pretty cool. We're validating the ideas that we had. But part of the problem, as I said, is that with modern browser engines that are not doing parallel layout, often they're reaching all over the DOM tree, and that breaks the guarantees that parallelism needs, which requires certain forms of isolation and knowledge that you won't ever be modifying like certain parents and things like that. And so with browser engines written in C++, often that can be challenging to rework the engine to make those guarantees and to keep those guarantees over time. But we found in Rust that we can actually enforce these guarantees from the start and using the type system. So it will be a compiler error if we ever try to write code which would break these guarantees for parallel layout. So another interesting problem we're working on is concurrent script and layout. So as I said before, there's that loop where you're running script and that modifies the page, and then you need to compute layout, then you keep running script, and there's this loop that happens. But often that isn't necessary to be synchronous like that. Often web developers are learning that synchronous layout is a bad thing. A synchronous layout is when you make a change to layout by setting like the left property of some element based on the computed value of a layout property of another element. So in this case, we'd be getting the bounding client rect of some other element on the page. And that forces a relayout to occur because we need to get the precise position of that element before we can continue executing script. So that breaks our attempt at concurrency. And there's lots of this all over the web. But web developers are also starting to learn that this is bad and this hurts their performance. So there are frameworks which are starting to work around this. And so we believe that if we can look for those cases where synchronous layout is not necessary, then we could start running script at the same time as layout and get very big wins that way. And the technical details of that are basically that instead of directly modifying the DOM, the same DOM that the layout task would be reading, we would just the script would only be mutating like certain copies of it when necessary, which would replace the original values once layout was finished. So the third really interesting area that we're looking at is different than performance, which were the previous ones. So as I said, security is really big. Everyone uses a browser, and therefore browser exploits are really good targets for security vulnerabilities. Governments love them. Security agencies love them. These are things where if you can discover a vulnerability that no one else has made public yet, you have a weapon that no one else has. So our feeling is that, at least in Gecko, a lot of the security problems come from C++'s unsafe memory model. And so a lot of those are use after free errors and iterator invalidation problems, where you're iterating over some collection, but then you modify the collection in some way that causes the pointers inside of it to become invalid, and suddenly your iterators are unsafe. So Rust, you'll have to trust me that Rust basically eliminates these classes of errors. We have ways of tracking what is a valid reference to something, and it'll simply be a compile error if you try to use a pointer which could be unsafe. You can learn more about that if you read the Rust manual. It's pretty exciting stuff. So by eliminating whole classes of errors, that's exciting. In addition, we have task isolation, which is shared nothing, so you don't have data races. And then it's really, really simple to turn Rust into a process isolation model for using tasks without having to actually modify the code of the browser itself. And that gives us a whole different class of protection. And then we're thinking, well, why not go even further? Why not take unsafe C code, which we need for certain performance reasons, and just run that inside of a sandbox NACL process? That you get multiple layers of protection. So Servo can be the safest browser ever. So there's really cool stuff happening. And so Servo is being developed by a very small team of Mozilla Research engineers. There's about 5 of us. There are a number of Mozilla community volunteers who are doing really cool things. Plus, there are a team of research engineers at Samsung who are working on this as well. So it's a fairly small team, but we're getting a lot done, and we're getting really good results. And we would love more people to help us out. It's a great way to learn a new and exciting language, and it's a great way to really push at the cutting edge of the web. So there are ways you can help. You can learn how to write Rust code and then contribute to Servo by writing Rust, because everything in Servo, almost everything, the DOM, the layout, the rendering, all of this is written in Rust code. And so there's a link there to the Servo issue tracker on GitHub, which we have a tag called easy, which is a great way to get started. If you don't want to learn a whole new language, you can write JavaScript and CSS code, because we have a test suite, and it's slowly growing, and we're working to integrate the existing W3C test suite. So it's also something that can interoperate with other browsers, so you can get nice multiple project helping bonuses there. So you can also just download the Servo source code and build it, and you can try things and see what breaks, and then file bugs. That's really useful to us. We don't have any binaries yet, but that'll be coming in the coming quarter, probably. And finally, if you just want to keep abreast of what's happening, you can look at the mailing list. It's mozilla.dev.servo. Look for the Mozilla mailing lists. It's on that list. If you want to, whoopsies. No. Okay. If you want to do something that's really helpful, this will basically require writing Rust code. Then we're slowly working towards fixing the problems remaining for the ACID 2 and ACID 3 test, standard tests. And we're working to integrate the W3C's test harness.js harness. So there are features of Servo which are missing, which we need for those. If you just want to implement your favorite DOM API and learn Rust in the process, that's great. It's actually quite a fairly easy process these days. If you want to implement missing CSS features or some layout things, we can work with you on that too. And this might be the wrong venue for it, but if you really like Windows, it doesn't run right now. It doesn't build. We'd love some help with that. Because eventually, it's one of those things we're going to have to do eventually. So that's Servo. I'm happy to answer any questions about it. You can find the slides with the links at the link there. I assume that's readable? Yeah. And yeah, tweet at me, email me. And I've got some Rust stickers up at the front here. If you want to show off your love of the language, I'm happy to hand those out. So yeah, come and talk to me. Yes, Jerv, get a microphone. Run, run, run.
Two questions. Firstly, you said you were going to build it behind the WebKit API for embedding. Is the WebKit API, is that causing you problems? That is to say, is the API suitable for this kind of thing, or are there things you wish were different? And secondly, do you yet have a kind of timeline for when someone might be able to use Rust to browse the web and not go, I must be using Rust because lots of things are broken?
For the first, what was the first question again?
WebKit API.
Right, WebKit API. We haven't put much work into it. It's one of those things we're thinking of for like an intern project or maybe summer of code, perhaps, thinking about it. It doesn't seem like it's insurmountable at this point. For the second question, which has escaped me, oh right, timeline. So we're hoping by the end of the year to have Servo be sort of relatively usable in a dog fooding kind of way, which is ambitious. So the more people that help us, the more likely that'll be the case. For an actual like product kind of thing, maybe 2 years minimum might be something to keep in mind.
Can you speed that up by taking big chunks of Gecko and wrapping them up in NaCl and, for stuff that isn't core, like, I know, WebRTC or, stuff like that?
Right. Certain parts of Gecko, yes, and we're already doing that. For example, we're using SpiderMonkey from Gecko totally, we just import it, as well as some of the graphics code. But there's large parts of Gecko which are really tied up in the whole Gecko XPCOM, I like to say fiasco, but it's hard to integrate with Rust that way.
Another question?
Yes, Deb.
When you talked about the layout parallelizing, like rendering the layouts differently, are you talking about following any criteria to separate them? Sometimes it's required. Like I would like to know if there is any adverse effect of that part, because sometimes one depends on the other node.
Right. It's hard to say because we haven't done too much experimenting with it, but I believe that we have code which can like look at a page and say, okay, this will require a sequential layout. This can benefit from parallel stuff, and we want to write some tools which will be able to you'll be able to like run Servo on a page and see like the Servo factor, which will show like this page was speeded up by this amount because of Servo's parallel stuff. That'd be really nice if we can get that happening.
Right.
Somebody else?
How would this perform on an architecture that has only one CPU? For example? Would there be some performance issue because it will not run in parallel at all?
That is a good question. I'm not one of the sort of core Rust developers with a really good understanding of the runtime that enables these things. I believe that they take this into consideration when developing it, but I don't have any solid answer.
Okay, thank you.
So one thing that I find pretty cool right now in Firefox, for example, is that we can render the user interface basically with the same renderer as we render web pages. Of course, we probably will never want to support Zool in Servo, but do you see some chance of getting something like that in Servo as well, where we can render user interface across platforms with Servo as well?
I was actually playing with a thought experiment this morning about like embedding Servo within Servo to make the browser interface. I think like with the embedding API, it should be a possibility to do something like that. But it's like we're not focusing on the like browser part. We're focusing on the engine and allowing someone else to work on the fancy bits.
A last one? Really a last one.
Are you planning to create a new JavaScript engine?
The question was, are we planning to create a new JavaScript engine? Everyone always talks about it as something that would be really cool to do, and the JavaScript team keeps going like, why not? But it's not really feasible at this point with how few people that we have working on it. We're really focusing on like the essential things. And a JavaScript engine is pretty key for performance. So we're trying to build on the things which are really good right now. But I mean, it could be a fun project.
Thank you so much.
Thank you.